Now let's continue our discussion by analyzing saturated solutions and solubility. In the previous video we talked about sodium chloride, and we can say that sodium chloride is very soluble in water. So if we took a sample of solid sodium chloride and dumped it into water, we dump a little bit in there and it dissolves. And we keep dumping more and more and more, and eventually this solution becomes saturated. So if we keep dumping in here, so let's just say we have 100 milliliters of water over here, and we can dissolve 36 grams of NaCl into that solution. So it's going to dissolve, and our sodium and our chloride are dissolving here, and now we add more than 36 grams. What happens? So let's just say in 100 milliliters of water, we add 50 grams of NaCl. So what's going to happen here? And if we add 50 grams of NaCl, 36 grams dissolve, and we're going to have 14 grams of solid remain. So instead of 36 grams here, we're going to add 50 grams of NaCl into this container. We're going to get 36 grams is going to dissolve, and there's going to be solid down here at the bottom, and we're going to have 14 grams of NaCl exist as solid. So we need a chemical equation to represent this process right here. So basically what we're going to say is we have NaCl as a solid plus water as a pure liquid is going to be in equilibrium with sodium ions in aqueous solution plus chloride ions in aqueous solution. If we say the forward reaction here, we can call dissolution, where we observe this dissolving, and the reverse reaction here is crystallization, because the sodium and the chloride are going to crystallize back into the solid. So what we can say here, and we have this equilibrium, and this reaction, this forward reaction and this reverse reaction are happening all the time in this particular solution. But we can say that a solution in equilibrium with undissolved solute is saturated. So remember what equilibrium means. That means the rate of the forward reaction, the dissolving, is going to equal the rate of the reverse reaction, in this case the crystallization. Okay? So if we have an equilibrium, we're considered to be saturated. The solubility is the amount, or what chemists refer to as the concentration, of solute in a saturated solution. So if we look at this kind of as a continuum of NaCl added at 25 degrees Celsius, so we have to make sure we remember to indicate a temperature here, because the temperature is going to influence the solubility. And this is the sodium chloride solid added at 25 degrees Celsius in 100 milliliters of water. So we make our benchmark right here as 36 grams of NaCl. Okay, this is our saturation point. We can say that the solution is saturated at this point, which means that we're at equilibrium. And we can say the amount of solid dissolving, or the rate of the solid dissolving, is going to equal the rate of the crystallization step. So we're at equilibrium right here. Anything below this is going to be unsaturated, and we're only going to have ions in solution. There's going to be no solid present. Okay. Anything above the saturation point we can say is supersaturated. And we're going to have solid present. Or we should say excess solid present plus the ions in solution. And in this case, the ions will be sodium plus and Cl minus. So this kind of helps us start the vocabulary that we're going to use when we talk about something having a saturated solution and what the solubility is. We're going to talk a little bit about the factors involving the solubility or influencing the solubility, and then we'll also talk about concentrations of solutions and how to express them in the upcoming videos.